Thank you for taking this opportunity to view our demonstration of CARIS Spatial Fusion Enterprise, or SFE. My name is Eric Ferguson, and I'm with Sales here at CARIS. I'm joined by Claude LeBlanc, Product Manager for Spatial Fusion Enterprise. Today we will be discussing the components of SFE. Following that overview, we will demonstrate the newest release of SFE, version 5.3. Let's start with a quick overview of the components of the application. Spatial Fusion Enterprise is comprised of two independent applications, a server and a viewer. When your SFE is deployed, you get both the server and the viewer. An important feature of SFE is its interoperability through OGC standards. Our server could be used with any OGC compliant viewer, and our viewer could be used with any OGC compliant server. However, the value and benefit of Spatial Fusion Enterprise is the power both the server and the viewer have when working together. One important note, as they are both separate and independent applications, they each have their own configuration manager. You'll see more of this as Claude demonstrates the software. Our server supports multiple data formats including CARIS files and Esri shape files, as well as other types of imagery and vector files such as AutoCAD, Mr. SID, MapInfo, Oracle, ODBC Connection, JPEG 2000, and GeoTIFF. After registering your data, you'll then be able to serve this data through server protocols such as WebMap services, WebMap tile services, Web feature services, and Web coverage services. WMS and WMTS support draw output formats such as JPEG, PNG, and TIFF for map display, as well as KML, GeoJSON, and GML for selection and extraction through feature info requests. Another server protocol is WFS, which supports GML, KML, and GeoJSON as output formats, which are used for selection and extraction of feature requests. Also note WCS, or Web Coverage Services, will be available in version 5.4 for gridded data. Now let's move on to the viewer. Our viewer supports the output formats of the server for map display and selection extraction. The viewer also allows the administrator to select a number of options for a base map, including Google Maps and OpenStreetMap. For those of you who may be new to OpenStreetMap, it's a free editable map of the world. Consider it as a community-driven collaborative mapping project. The viewer also supports points of interest through GML, KML, GeoJSON, and GeoRSS Simple. Claude will be discussing these further in the demonstration. Now I'll pass things over to Claude for a demo of version 5.3.
Thank you, Eric. As Eric mentioned earlier, I am Product Manager for Spatial Fusion Enterprise. The first half of my presentation will be demonstrating our server capabilities and how to register your data and then configure your OGC services for publication. This will include WebMap, Web Feature, and WebMap Tile services. We are excited about the WebMap Tile services, or simply WMTS, as it will greatly improve the speed in which your data draws, and because we believe we are the first to implement the latest version of WMTS standard in a commercial application. I will also show you how an administrator can add metadata to their web services, including contact information and service and layer metadata. The second half of my presentation will be demonstrating our viewer features and how an administrator can create points of interest, perform point and range selection and data extraction, search for metadata, how to print your maps using our dynamic map print tool, and how to incorporate Google Maps or OpenStreetMaps as your base map. Let's begin. I would first like to take this opportunity to thank both the City of St. John and City of Fredericton for providing the sample data for our demonstration. As you can see, I have launched our viewer and we'll start with a Google-based map. As I go through the configuration manager, we will be adding services and features to build upon the base map, and we will be highlighting our WMTS services. Now I'll log in.
Note one of the first things that you see as you enter the main page is the Data Source Status table, which helps you quickly identify the status of your registered data before you begin creating your web services. This allows you to identify any issues that may need to be addressed prior to creating your web services. If they're working, they'll be green and indicate registered. If there's an issue, instead you'll see a red X and it will show as unavailable.
Thank you, Eric. This is the main page of the server. It is comprised of 3 sections which include the map server, security, and general. As security and general are common to both the server and the viewer, I will start by giving you a brief overview of each. Under the security section, the administrator has the capability to add new users and new roles which can provide secured access to either application. Under the general section, the administrator may be required from time to time to set up or modify communication protocols or administrative parameters. These would be done under the settings page. For easy access to CARIS support staff, the support page provides links to the CARIS customer support email, CARIS online help desk, and a send logs feature which sends your application and service logs directly to the CARIS customer support team. The logs page provides an administrator with quick access to application and service logs to help promptly identify any issues that may need addressing. The license page provides the administrator a quick and easy way to enter CARIS provided license string that is used to activate the applications. The last feature under the general section is the contact information page and is unique to the server. As mentioned earlier, the contact information page is a form of metadata that is associated to an OGC or web service every time one is created. This will help your organization to validate and qualify the data source and services to an end user. The system administrator will be able to follow a simple workflow to publish their OGC or web services to the web by first registering their data source and then creating their web services. To start, you must first register your data. We do so on the Register Data Source page. Having prepped your data, you simply provide a data source name. We'll use demo WMTS. Select the data type supported. We'll select file layer for our example. And browse to the description file relating to the data you want to register. Having registered your data, you'll be provided with the available map layers. These layers will be used in creating your web services. Note that all registered data sources, along with their status, are provided in a table upon entry of the data source page. This table format of pre-configured items is common through both the server and viewer applications. The next step in the workflow is to create your web service from your registered data. You can add a WMS, WMTS, or WFS service, and as Eric mentioned earlier, you will be able to add a WCS service in the next planned release. To demonstrate and build upon our Google base map, I will create a WMTS service. The system administrator will need to complete the description component of the service, including the name. We'll use demo WMTS service. And the title cache location. Eric, perhaps you can briefly explain caching while I fill out these next few fields.
Sure, Claude. You may already be familiar with the fact that some servers, such as Google, load their maps as several individual tiles rather than as one large map in order to decrease the load time of the map. Using WMTS and the layer group feature, many layers can be represented as a single layer, and the tiles for that single layer can be cached for an even greater improvement in speed.
Thanks, Eric. I have selected a period and a day of the week when the cache will be cleared. Choosing the never option means that all draw requests will always come back to the server and will be drawn from the cache if available or draw for the first time. Next, the system administrator will select the coordinate system that they would like to have their data or maps drawn in. Presently, for our WMTS service, we only support WGS84 and Web Mercator. I'll include Web Mercator for our demo as it is supported by Google Maps. We are now ready to add map layers to our service. I will include the map layers from the data source I previously registered, the demo WMTS, and some other layers from other data sources. An administrator can select layers from any number of data sources, keeping in mind the concept of grouping related data in a single service for improved draw performance. As you can see, I will be adding other layers from structures, and transportation. Note the icon next to the selected map data. This opens an edit window for a second type of metadata mentioned in my introduction. Layer metadata can be added per layer, which could include a title, keywords, and an abstract. I will add some metadata to one of these layers in order to demo it in the viewer. Now, the administrator can enter the third aforementioned metadata, that being service metadata, before saving. This is data relating to a specific service being created, which would include a title, online resource, keyword, abstracts, fees, etc. We are now ready to save our WMTS service. Once saved, the Layer Groups panel is activated, allowing the administrator to take advantage of the performance enhancement feature, which allows them to create a single layer from all the layers in the map layer panel. By flattening all layers into a single layer, the amount of callbacks to the server will be greatly reduced, thus increasing the draw speed of your maps. I will create a layer group to be added to our base map for demonstration purposes. Including the name, I will be adding all the layers available, and I'll be saving.